Okay, on previous term, we have taken center of mass. Now, today we will take some numerical questions related to center of mass. On previous question, center of mass formula was the x coordinate of center of mass, that is m1 x1 plus m2 x2 and so on, divided by m1 plus m2, that's up to mn xn, and here is plus mn. Same thing by ycm will be m1 y1 plus m2 y2 plus mn yn upon m1 plus m2 plus mn, and zcm m1 z1 plus m2 z2 plus mn zn upon m1 plus m2 and so on plus mn. It is in scalar form. We can easily find the coordinates of center of mass, x coordinate, y coordinate and z coordinate. It is for numerical use. Now one question, numerical question. Three masses are placed at the three corners of a triangle of side 2 meter. Masses are m1 or 2 kilogram, 4 kilogram and 5 kilogram. Find the center of mass. Find its center of mass. Now the solution. Suppose this one is triangle whose side is 2 meter. Suppose this one is origin O. It is y axis and here is x axis. The points are O, A and B. Masses are, here is 2 kg, 2 kilogram, here is 4 kilogram and here is 5 kilogram. Then the coordinates of, because side is 1 meter, 2 meter, side is 2 meter. Coordinates of points A, B and C are, that's 0, 0, 1 and 0, 2 and 0 and 1 and 1. Now we can assume that, so we can write m1 is 2 kg, x1 is 0 and y1 is also 0. m2 is 4 kilogram, x2 is 2 and y2 is 0. In similar way, m3 is 5 kilogram, x3 is 1 and y3 is also 1. Now we can easily find the x coordinate. X coordinate, that's xcm will be m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3, m1 plus m2 plus m3. So xcm will be 2 into 0 plus 4 into 2 plus 5 into 1 divided by 2 plus 3, 2 plus 4 plus 5, 4 plus 5, that's 8 plus 5, that's 13 upon 11. The x coordinate of center of mass. Now the y coordinate, ycm will be m1 y1 plus m2 y2 plus m3 y3 divided by m1 plus m2 plus m3. m1 plus m2 plus m3 is 11, and the values of m1 is 2, y1 is 0, so ycm will be 2 into 0 plus 4 into y2, that's y2 is 0, 0 plus m3 means 5 into y3 is 1 divided by 11, that will be 5 by 11, and also meter and meter. It means the center of mass will be of mass of the system will be 13 by 11 and 5 by 11. That's the answer, required answer. Now the second question, question 2. So first of all, note. Now we'll take some type of questions. If some mass is removed, then how we will find the center of mass. Here is question that's 2. Mass of a solid sphere is capital M and the radius is R. Is R. If a sphere is removed from it, whose radius is, find the center of mass, the center of mass of the remaining part, Cm of the remaining part. Now the solution, it is the sphere whose radius is capital R, its radius is capital R, the center. So a sphere is cut in such a way that its radius is R by 2, so center will be at here. This one is the sphere whose radius is R by 2. Then the removed part. Now we have to find the radius of this shaded part. This one. The total mass is capital M. Total mass is capital M. Means the mass of the sphere is the mass of a sphere, solid sphere, is M1. That's suppose is capital M. Its center mass. Its center of mass will be at O. Its center of mass Cm will be at O. Suppose the mass of the removed part is M2. Mass of removed part is M2. We can easily find the value of M2 in terms of capital M. Means the total sphere have mass M. We can easily write because the mass of volume 4/3 pi RQ is capital M. Is capital M. So the mass of unit volume will be M upon 4/3 pi RQ. But we have to find the mass of the removed sphere. Mass of volume 4/3 pi R/2 Q. That will be small m. M2 will be M upon 4/3 pi RQ into 4/3 pi RQ divided by 8. 4/3 cancel, RQ cancel. It means the M2 will be M by 8. M by 8. Now we have to find the center of mass of the remaining part, this shaded part. The center of mass of this removed sphere will be at this point O dash. Now the center of mass definitely will be on the line joining O and O dash on this line. Suppose this point is A, this point is B. Definitely the center of mass will be on line AB. How we will find? We have removed the part. So we will take mass negative. Here is, we will write center of mass. Means x coordinate of center of mass, xcm, will be m1 x1 plus m2 x2 divided by m1 plus m2. That's m1 is the solid sphere, that's capital M. We have to find the distance of center of mass of the remaining part from O, the center of the complete sphere. So its center mass, that will be 0, plus m2 x2. m2 is removed, so it will be negative, minus m by 8 into the distance from the center O, this point. This distance will be, that's r by 2. So we will write here r by 2. x2 is r by 2 divided by m1 means m, and the m2 is negative, that's m by 8. Of xcm will be minus m into r divided by 16 into 7 m by 8 means this one. Or we can also write this one, m cancel, this one is cancel, 8 2 times cancel, means rcm will be minus r by 14. Here negative sign shows that the center of mass of the remaining part will be left towards point O. Here will be the center of mass of the remaining part. Here will be 7, this one is, this distance is 7 r by 14. That is r by 14, this distance. So when any part is removed, then we will take the mass negative. Now next topic is torque. That's torque. When a body is free to rotate about an axis, and if we apply the force on the object, then definitely it will try to rotate. This tendency of rotation is known as the torque. An object is free to rotate, about any axis if we apply a force on it. It will start to rotate. This tendency is known as torque. This tendency is known as torque. Actually, torque is the combined effect of force and perpendicular distance from the axis of rotation. It is the combined effect of force and perpendicular distance of force from axis of rotation. If this one is any object, it is free to rotate about this axis, the axis of rotation. A force is applied at this point, in this direction, at this point P, in this direction. The force is the direction of force at this point P. The distance is r at an angle of theta. Then the torque is force into perpendicular distance means T will be F into perpendicular distance. This distance will be O, suppose M, this is OM. We can easily find the value of OM from triangle OP and M. From triangle OPM, sin of theta is OM divided by R, or we can easily add that OM will be R sin of theta. On putting this value, tau becomes F R sin of theta. Number 1, if we in vector form, tau will be tau is F R sin of theta n cap. यहाँ वो आ रहा था low space, or we can write tau will be R cross F. The direction of tau is given by right hand rule. How? We want to find the direction of tau, then spread the fingers and thumb of our right hand in such a way that fingers show the direction of first vector, that's R, and rotate the fingers in such a way that they show the direction of rotation. Fingers must be along R. If we fold the fingers, then in this figure the object is rotating, the direction of motion rotation, it is rotating anti-clockwise. So fingers must be along R, and we rotate the fingers in the direction of rotation of the object, then thumb will indicate the direction of tau. So we can easily find the direction of torque with the help of right hand rule. Here there may be 3 cases. Case first, if theta is 0 degree, then from first tau will be R F sin of 0, that's 0. If R and F are in same direction, then torque will be 0. And case second, theta is 90 degree, then tau will be R F sin of 90 means R F maximum. And in third case, if theta is 180 degree, then tau will be R F sin of 90. Sin 90 means sin 180. Sin 180 means sin 90 plus 90 cos 90, that's 0.